Thanks, Brian. Good afternoon, everybody. Thanks so much for joining our workshop today. My name is John Matthew, Director of Cloud and Automation and DevOps here at Red Hat. Our team gets to do a lot of cool stuff for clients. One of those is we get to work with Red Hat products, namely Ansible, which you'll see today. Before I introduce you to our workshop gurus, I wanted to give you a little background on Red Hat and the broad range of services that we provide. Next slide, Brian. So Red Hat is one of three companies owned by Insight Investments. We've got Insight Financial Services there in the middle. They're basically a leasing arm and asset management company, which is where the company started. That broke off into another group of companies called Second Gear, which is a very cool product which takes old gear and refurbishes it. And as you can imagine, due to the pandemic right now, laptops are in high demand for schools and other places, so that they're doing very well. And then you have Red Hat, which is your traditional VAR, which offers quite a few advanced consulting services, as well as your classic data center areas of expertise. Next slide, please. So in the Red Hat space, we have about 5 practices and growing. We've got the traditional data center space, which is, as you can imagine, everything that is data center, from physical assets to networking, racks, backups, everything that was data center. In recent years, we've branched out into other areas: security, DevOps, cloud, automation, and analytics. And specifically in the DevOps and cloud and automation space, next slide, please. We help our customers there with, as you can imagine, moving to cloud, some of the Office 365, Microsoft areas, but a big area for us is the Red Hat space, namely Ansible, as you'll see today, as well as OpenShift, which is the container platform from Red Hat. We do a lot in the GitOps space. If you're not familiar with that, please reach out and let us know. We would love to get you going there. A lot of that revolves around continuous integration and delivery, again, and containers. In the cloud and automation space, right, we help companies get to the cloud, make sure their cloud spend is adequate, potentially move them over to a software as a service model, and generally get comfortable using the cloud as best they can. So just want to give you a quick overview of what our services are and what we're available. But today we're going to spend a great afternoon with Ansible, and I'll let our cloud gurus take that over. I believe that's going over to Jim Garrett. Brian?
All right, yeah. Thanks a lot, guys. Appreciate everyone's time. Actually, I apologize. I just shared the wrong screen. All right. So let me start by introducing myself. So again, my name is Jim Garrett, and excuse me, I am a principal solution architect at Red Hat. I've been with Red Hat for almost exactly 4 years now. And during that time, I have focused almost primarily on just a couple of the products, one of which is the Ansible automation platform. Just a little introduction to myself. I've been doing software engineering and architecture for a very long time, almost over 30 years. I was a graduate from University of Cincinnati back in the computer science department, back when it was the very first year that they offered the program. I like doing just about anything outdoors. And one interesting fact about my background is the very first job I had, I actually worked in the U.S. Pentagon. So I've done a lot of government work, government contracting work in the past, and really found that to be very interesting. And one other thing I've done, I don't know if anybody else has done it, but I've hiked the Grand Canyon from rim to rim with a bunch of buddies of mine. Very interesting thing to do. Highly recommend it if you ever get the opportunity to go. So what are you going to learn today just in this presentation? I'm going to go over a bunch of different topics. I'm going to spend about 30 minutes doing a lecture, and then we're going to spend the last hour to hour and a half where you guys get hands-on lab time to actually get in and start using Ansible and experiment with how it works. For those of you who have never used Ansible, let's talk about what the Ansible automation platform is. First of all, I love this picture because the picture is worth 1,000 words. Ansible at its core is an automation engine. And What you need to think about when you think about Ansible is think about your system operations or infrastructure people who spend all their time with hands on the keyboard. And when someone, for example, wants to have them deploy a new server or deploy a new configuration, oftentimes it's all of the different commands that they've memorized that they just type over and over and over. Well, that's where Ansible Engine comes into play. With Ansible, you can create what's called a reusable playbook, where you can document all of those different actions that your system administrative people perform on a daily basis, and you can automate those actions. You can put them into this engine where you can then replay them at will. So at its core, Ansible is an automation engine. A couple of different use cases for Ansible are, for example, we have the ability to automate your IT infrastructure, your provisioning of servers, your virtual machines, etc. We also have the ability to automate the configuration of your networks. And we have several different network providers with whom we are partners with, for example, F5, Arista, Cisco. So those are the main use cases. But again, when I think about Ansible and the automation platform, we start off with the engine, but the question is, what do we really automate, or what can we automate? And it's actually a very broad answer to that question. There are over 4,000 different modules that Ansible has at its disposal that provide you the ability to automate various aspects of the things that you want to automate. So some of the most useful use cases are the ones on this page, where the first one is orchestration. You think about all of your different configurations that you want to create, and you want to be able to create a consistent, repeatable process for deploying those configurations. We've also got configuration management, the centralized configurations of your files and managing those files. We've got application deployment. We have the ability to create Ansible playbooks, which can manage the deployment of your applications. And again, by creating that consistent, repeatable automation playbook, we can then deploy your applications to your test or to your production environment with simplicity. We have the ability to do provisioning. We're basically taking the applications that you want to deploy and being able to provision them out to the servers that you want to deploy them to. We've got hooks into various continuous delivery or CI/CD pipelines, so you can write Ansible playbooks that can automate your entire CI/CD pipeline DevOps environment. And the last bullet point on this screen is security and compliance. Now, this one's kind of interesting to talk about because technically, Ansible, at Red Hat, we are not a security company. But with Ansible, what we have is hooks into a variety of different security tools so that you can then use an Ansible playbook to define, again, consistent, repeatable tasks that allow you to define your security infrastructure. By the way, we also have existing playbooks. For example, you may all know that we're an open source company, which implies individuals can contribute into our source code trees. We've had individuals contribute into our playbook repository, and they have playbooks that can be used to set up, install, configure, and harden, basically applying security principles to your servers. In addition to that, we have hooks into other security tools, which means we can create playbooks that can go out and analyze your log files, that can go out and basically apply security patches or different security playbooks to the environments that you have. So for example, if somebody is attempting to attack your network and then maybe it's a denial of service attack, we can quickly write a playbook which will patch your entire system and block that person from accessing your system. And you can execute that playbook against all of the servers, all of your network devices, whatever's appropriate in that situation. So I've talked a little bit about Ansible playbooks, and what we call that is our automation language. We also have, as part of the automation platform, a tool called Ansible Tower. And what that is it's a browser-based user interface that allows you to manage all of the aspects of the playbooks that you're going to be creating. And what I mean by that, when I say managing the aspects, you can physically take those playbooks and you can store them. You can then provide access to users to those playbooks. So, for example, if you have a playbook that's going to run as root on a specific server, but you don't want to give someone access to that root account, well, you can do that through Ansible Tower by simply allowing a user to log into Ansible Tower, run the playbook, and actually give it the credentials through some type of secure mechanism that allows that playbook to log into that remote server securely and then execute all of the different tasks on that server. Now, at its core, Ansible is extremely simple. Again, it comes in the form of that Ansible playbook, which comes in human readable form. It's actually an ASCII file that's written in a syntax called YAML. And YAML stands for yet another markup language. You don't have to have any special coding skills to get up and running. And basically, once you create that playbook, you're going to add a series of tasks to that playbook. And those tasks are going to be executed in order. With that simplicity, you can get productive very quickly. We've had individuals who, within 10 or 15 minutes, they've written their first playbook and they're able to automate various tasks that they want to have done. Now, along with that simplicity comes power. I mean, I mentioned some of the different use cases we have: configuration management, application deployment, workflow orchestration. That creates a lot of power in what you can do. Again, we have over 4,000 modules available to Ansible, which can be brought to bear and placed into these tasks. And then the last component or last aspect of Ansible is it's agentless. And this is actually a pretty big deal. If you compare other automation tools, oftentimes those tools will have agents that need to get deployed onto your server infrastructure. The challenge that you have with that is those agents will be consuming resources. They'll be consuming CPU, they'll be consuming memory, disk space. In addition, when that server is modified, for example, if you have to patch or upgrade that server, you have to make sure that all of your agents are still going to work. When we interviewed system administrators and we asked them the question, approximately how many agents do you have on each one of your servers? You'd actually be shocked at the answer. Usually it's between 10 to 20 agents that are all consuming resources. So the fact that Ansible is agentless is a big deal. The way that it works, the way that we're able to make it agentless is when Ansible does its thing. When it communicates to a server, we do that over a secure shell using OpenSSH. If that server happens to be a Windows box, we use WinRM to connect to it. Now we have this saying, we like to call it the Ansible way. And what that implies is, first of all, Ansible is cross-platform. Its agentless mechanism for communicating with these servers gives us the ability to communicate with a variety of different kinds of servers, from Linux to Windows to Unix boxes. Again, it's in human readable form in a YAML file. What happens is once you have that YAML file created, it actually perfectly describes and documents every aspect of your environment that you're looking to modify. And along with that description of the application, every change that's made to a playbook ensures that everyone can see that change and actually take advantage of that change. Now you're probably wondering, how does this playbook communicate with all the different servers? And the way that we do that is with what we call an inventory file. And Ansible has about half a dozen different ways that it can get its inventory information. And when I say inventory, I mean the list of servers or network devices that you want to communicate to and execute tasks upon. The various ways we have, it starts off with the most simplistic form, which is an ASCII text file. And I'm going to show you an example of that in a few slides down. But we can also pull from a database. We can pull from web services. We can pull from a variety of different things, which give us that list of servers that are in your network. And then finally, the Ansible way is we have orchestration that plays well with others. Being an open source company, we feel that it's important that all of our products work well with other products out in the ecosystem. And of course, Ansible follows that paradigm. With Ansible, you can communicate and interact with other automation tools like Puppet and Chef and CI/CD tools like Jenkins. So it's something we feel very strongly about. So let me jump to another use case, and that is managing networks. If you've ever managed networks, you probably know that the management of those networks really hasn't changed in over 30 years. And it's definitely a big spaghetti mess. In fact, Gartner did a study, and they brought out a very interesting fact about the management of networks. In their study, they asked the question, what tools do you use to manage your networks? 71% of the network providers that were interviewed said that they still manage their networks by using command line interface. Which again, if you go back to that first slide that I showed, where it's just those robotic hands typing on a keyboard, that means that to configure your network devices, you're typing on a keyboard 71% of the time, which is a big deal when you think about all the different network devices and you think about the commands that each one of your system administrators have to memorize on a daily basis just to maintain those devices. So let's talk about some considerations with that. When you're talking about networks and the configuration of those networks, compute is no longer the slowest link in the chain. With current business demands and with the invention of the cloud, all of a sudden the entire picture needs to be very quickly adaptable, configurable, and deployed. That means that even the network is included with that. So no longer can you waste time typing hands on the keyboard. You need to have automated tasks which can be used to manage that network and to configure it in a very consistent and repeatable way. And again, that's where Ansible comes into play. With Ansible, you're able to bridge the silos that exist between those network devices and between the users or the administrators who have to configure them. So let's talk again about some common use cases. Anything an operator can do manually, Ansible can automate. For example, the backup and restore of your configurations, automatically upgrading your OS, ensuring compliance between your configurations, maybe even applying patches, and creating dynamic documentation. That last bullet point is actually, again, a pretty big deal. When you think of all of the information that's recorded about each one of your devices, I mean, not only your servers, but your network devices. Again, if you think about what's important, maybe it's the IP address, maybe it's the version of the operating system that's running on that device. With Ansible, we have a very unique tool that allows us to generate all of the information about that device. It reaches out to the device, it analyzes it, and it brings back a list several pages long for all the information that is about that device. So again, we have the ability to dynamically generate documentation about all of the devices in your environment. Now again, one question people often ask is, how does Ansible work? And there's actually two answers to that. If you're communicating with a network device, Ansible actually basically operates locally. So you have what's called a control node. That control node has local execution, which reaches out to each network device and basically runs those command line interface commands to configure that device. The difference between a network device and, let's say, a Linux host or a Windows host is that with Windows and Linux hosts, we actually create that SSH connection out to that server, and we then copy code over, we execute the code, and then delete the code off that server. So it's a very different paradigm between the two. Let's talk a little bit about the Ansible automation engine. Again, we start off with a playbook. Playbooks are written in YAML, and tasks are going to be executed sequentially. The playbooks and the tasks in those playbooks are going to access or execute modules in the Ansible world. And again, we have over 4,000 modules in that world that you have to choose from. And that number grows on a daily basis. Again, keeping in mind that we're an open source company and that individuals outside of our company can contribute to our upstream source code. We have individuals on a daily basis who are adding new modules to our Ansible playbook, or to the Ansible environment, Ansible automation framework. And whenever we release a new version of our code, we obviously have the ability to include those modules in that code. We have plugins. These are the gears in the engine. This is the code that plugs into the core engine and runs on the different systems that we communicate with. So let me give you a picture, because again, a picture is worth 1,000 words. Running Ansible in its most simplistic way. Once you've installed Ansible on your server, there's going to be a command line command called Ansible, which if you run it, you can actually run an Ansible script. So in this example, you can see we're saying Ansible space all. And what the word all means is we want it to execute against all of the servers in our inventory. Now, of course, this command doesn't tell you what the inventory is. So it's important to note that by default, Ansible is going to look in your current working directory for a file with a specific name, which is going to list all of your inventory in it. That file is actually a configuration file, and it may point to a folder that has an inventory file, or it may point to a database or to a web service or a variety of different things. Then you have the -m. -m stands for module. And in this case, we're going to run the ping module. So in this example, it's going to run the ping module against every server in our inventory. And in this case, there's only one. So the picture shows that it creates an SSH connection to that server, runs the ping command, and then returns. Getting slightly more complicated, we have another command line command called Ansible-playbook, and it takes as a parameter the playbook that you've created that has all of your tasks in it. And with that playbook, what it does, again, is it looks in your host inventory file, and it will look for the various servers that you want to execute this playbook against. It then will take every server in the host inventory file, create that SSH connection to that server, and then run the tasks which are defined in your playbook. Now you may wonder, what does an inventory file look like? Well, this is a very simplistic inventory file. And in this syntax for an inventory file, we have, first of all, the word in square brackets. For example, you see the word web. That actually creates a group of inventory servers. And the servers that are listed beneath it, obviously, are the servers in that group. So we're going to have 2 servers in the web group and 2 servers in the DB servers group. You then can look, here's an example of a playbook. We start off at the top with the name of the playbook. And in this case, this playbook says we're going to install and start the Apache web server. The first parameter in this playbook is a host parameter. And this says that we want to execute this playbook against all of the hosts that are in the web inventory. And again, going back to that previous slide, there were 2 servers in the web inventory. We have the ability to define local variables that can be used later in the execution of the playbook. We can even define what is the remote username for the user that we want to execute this playbook against. Now, of course, you notice there's no password communicated in this file. You could actually communicate a password in clear text if you wanted to. However, the preferred way of doing it is we ask people that if you're going to do this, you probably want to create some type of secure key that can be shared between the 2 servers so that you don't have to communicate a password when you run the playbook. And incidentally, if this playbook were to be run inside of Ansible Tower, you wouldn't have a remote user conveyed at all, because Ansible Tower would be in charge of communicating the user when you execute the playbook. And you can see from this playbook that we've got 3 tasks that we want to execute. The first task is we're going to install the Apache web server. And to do that, we're going to use the yum module. And if you've ever been a system administrator working on a server, you've probably used yum. Yum is used to install various servers and packages on the server that you want to process. So in this case, we're going to say yum, and the package we want to install is httpd, and we want the latest state of that package installed. Next, we want to copy a configuration file that we've created out to each one of the servers. And then we want to start that Apache web server. And to do that, we use the service module, which is the same thing as running the systemctl command on your Linux server. And again, when we take that simple playbook that we created before and we apply it to an inventory where there are multiple servers, you can see that on this picture, it creates that SSH connection to each server, executes the tasks, and then exits. Now, there is a configuration parameter where you can define how many servers it operates on simultaneously at the same time. So that just makes it quicker, because you can actually, if you have an inventory of 1,000 users, or I'm sorry, 1,000 servers or 1,000 network devices, you can increase or speed up its processing time by allowing multiple servers to be processed at the same time. Now, I mentioned, we have like over 4,000 different modules. This page gives you an example of some of them. If you wanted to see a complete list of all the modules that we have, you could go out to docs.ansible.com, and you can see, for example, on this page, it has cloud modules, clustering modules, crypto modules, database modules, a whole bunch of them to choose from. However, if you've already installed Ansible on your server, you can run the ansible-doc command on that server and get the same information, where it's going to give you documentation on the various modules that are available. Now, of course, you're going to run into a situation where maybe you want to do something and there's no existing module available for the command that you want to do. Well, you have options in that situation. For example, we can pass in what's called a command to Ansible, and that's going to take the command and it's going to execute it on whatever hosts are in your inventory. You can also create shells or scripts, or you can give raw commands to the Ansible module. And you can do that all inside of the playbook as well. So there's an actual module called command, which allows you to do exactly what we just described. Now on this page, I list a couple of other different ad hoc commands that we have at our disposal. The one I want to focus on is the second one. And you'll notice that it says the module that we're using is called setup. With the setup command, or the setup module, you can produce facts about the servers that are in your inventory. Again, I mentioned this previously. This is what will allow you to create documentation about all the servers in your network. The setup command, I should say the setup module, it'll produce several pages of information about every single one of your servers. And of course, you can filter that information. You can say, I just want to get, maybe the MAC address or the IP address back from the setup module, and it will give you just that. However, with this, you can see it becomes very powerful, because now you can generate reports that convey all the information about your servers. Again, I mentioned there's a variety of different modules we have at your disposal, from cloud to Windows to network, security modules, and monitoring. But here's what I call the money slide. This is a really interesting statistic about Ansible. And that is, if you purchase the Ansible automation platform, which includes Ansible Tower, what we've seen is our clients will get a 146% return on their investment in less than 3 months by leveraging Ansible and Ansible Tower. And there's some examples on the left which describe why that is. For example, we found that our clients get a 94% reduction in recovery time following a security incident. Now, what I mean by that is if you look at what your system administrators go through whenever there's a security incident, maybe they have to analyze log files, they have to turn logs on so that you're getting additional information. Once you've analyzed the logs, you then have to create a plan that talks about how you're going to fix that particular security incident. And then you have to apply that plan to all of your servers across the network. What we found was that there's a statistic that says only 5% of the security incidents actually get acted upon because of the complexity that's involved with acting upon those incidents. However, with Ansible, since you have the ability to automate the response to those incidents, you can actually save or reduce the recovery time by 94% for each security incident that you encounter. We've also got an 84% savings by deploying your workloads to generic system appliances using Ansible Tower. We've got a 67% savings reduction in man hours required for customer deliveries. I mean, each one of these statistics is a big deal. When you think about reducing the overall time by 67% on anything, I'd say that's a win-win.